Today we'll be talking about buffer solutions. Last class we talked about acids and bases and the concept of pH, and we did a couple of problems based on those concepts. ఈ క్లాస్లో మనం బఫర్ సొల్యూషన్స్ గురించి మాట్లాడతాం. బఫర్ సొల్యూషన్స్ గురించి మాట్లాడే ముందు ఒక చిన్న ఇంట్రొడక్షన్ బెటర్. లెట్స్ సే వీ టేక్ అ సొల్యూషన్ ఆఫ్ NaCl. NaCl అంటే న్యూట్రల్, సో pH ఈక్వల్ టు 7. ఇప్పుడు let's say we add 1 ml of 0.1 molar HCl is added to 1 liter of NaCl solution. Okay. Now, clearly HCl acidic కాబట్టి pH తగ్గుతుంది, right? ఇప్పుడు you can solve this. You can find out the pH of the resulting solution. You will find that the pH decreases to 4. Okay. ఇనిషియల్గా pH 7, pH 4కి వచ్చింది, అంటే concentration of H plus was 10 to the power minus 7. Finally, concentration was 10 to the power minus 4. Similarly, if you add 1 ml of 0.1 molar NaOH, pH 4 అవ్వకుండా 14 minus 4, 10 అవుతుంది. Basically means POH will become 4. Okay. Now, problem ఏంటంటే generally if you take any biological system, that biological system will operate only at or around a given pH. ఒక గివెన్ హెచ్ ప్లస్ కాన్సన్ట్రేషన్ దగ్గరే ఆ సిస్టమ్ అనేది ప్రాపర్గా ఫంక్షన్ అవ్వగలదు. ఫర్ ఎగ్జాంపుల్, ఇఫ్ యూ టేక్ యువర్ బ్లడ్, pH ఆఫ్ ద బ్లడ్ ఈజ్ ఆల్వేస్ అరౌండ్ 7.35. నా ఇక్కడ చూసాం కదా, pH 7 అన్నప్పుడు సడన్గా pH 4కి వెళ్ళింది. వీఆర్ యాడింగ్ ఓన్లీ 1 milliliter. దట్ ఈస్ అ వెరీ లెస్ క్వాంటిటీ ఆఫ్ 0.1. ఇట్స్ నాట్ ఈవెన్ 1 molar. This is very dilute and a very small amount of solution we took of HCl. Even then the pH falls to 4. So in biological systems, how is this pH maintained even if we add external substances? This is maintained with the help of buffer solutions. Buffer solutions help maintain a constant, an almost constant pH. Buffer solutions. So the definition of buffer solutions is a solution which resists change in pH when a small amount of strong acid or base is added. That is a buffer solution. Okay. Now, we don't need to go deeper into this. Why does buffer solution resist pH, change in pH, and how it resists? We're only looking at the pH value of these buffer solutions. There are two types of buffer solutions mainly. One is acidic buffer. The second is basic buffer. All right. Now, acidic buffer, as its name suggests, pH is less than 7. Basic buffer, pH is greater than 7. Now, how is acidic buffer created? An acidic buffer is prepared by using a weak acid plus salt of that weak acid with strong base. This is salt of weak acid, of that same weak acid with a strong base. Example, acetic acid plus sodium acetate. అంటే అసిటిక్ యాసిడ్ CH3COH, దాంతో పాటు సొల్యూషన్లో CH3COONA ఉండాలి. ఈ H ప్లస్ పీకి NA యాడ్ చేసాం కదా, that this is obtained when you make this react with NaOH. ఇది strong base, ఇది weak acid. So this is salt of strong base and weak acid. Then you will get an acidic buffer. Alright. Now, clearly, most of the time this is a basic salt, because strong base, if you add to a weak acid, you'll obviously get a basic salt. But you're adding acid. Also, before I said pH less than 7, pH greater than 7. This is generally true, not always true. It depends on the ratio in which you add the acid and the salt. Okay. Now, the other example is carbonic acid plus sodium bicarbonate, H2CO3 plus NaHCO3. Another one is H3PO4 and NaH2PO4. Now, H3PO4 is generally considered strong, but it is not as strong of an acid as NaOH is a base. అంటే H3PO4 అనేది how strong it is as an acid, ఎంత strong as an acid. NaOH is stronger as a base. అంటే బేసిక్ ప్రాపర్టీస్లో NaOH ఎంత స్ట్రాంగో అంతకు మ్యాచ్ అవ్వలేదు H3PO4 as an acid. Right? Now, next is acidic buffer. So next is basic buffer. Now, basic buffer is prepared by mixing a weak base plus its salt with a strong acid. Weak base, strong acid, salt, and the weak base itself, its a mixture as a solution is called basic buffer. Now, example is NH4OH plus NH4Cl. This is the best example possible, and generally the most of the times ఈ ఎగ్జాంపుల్నే వాడతారు బేసిక్ బఫర్గా. ఓకే, నౌ మూవింగ్ ఆన్ టు ద pH ఆఫ్ ఈచ్ బఫర్ టైప్. pH. Now, the first one is acidic buffer. pH equal to pKa plus log salt upon acid. This is concentration of salt, this is concentration of acid, and this is pKa of that weak acid. Okay. Similarly, for basic buffer, is equal to POH, pH కాదు ఇప్పుడు, pKb plus log salt upon base. Okay. Now, as I told you before, pKa is equal to minus log K and pKb equal to minus log Kb. ఈ ఫార్ములాస్ ఇంపార్టెంట్, గుర్తుంచుకుంటే బెటర్. డిరైవ్ చేయొచ్చు కానీ ఇట్స్ నాట్ ఇన్ ద స్కోప్ ఆఫ్ ద సిలబస్. It is possible to derive it, but we'll not be covering that in this lesson. Okay. This is the main thing required for MSET. Right. Now we'll look at some applications of buffer solution and then examples. Applications. Right. Buffer solutions are widely used in chemical analysis, in industrial synthetic processes, and in enzyme catalyzed reactions to control pH. Right. మనం డెఫినేషన్ ప్రకారంగా వెళ్తే బఫర్ సొల్యూషన్ రెసిస్ట్స్ చేంజ్ ఇన్ pH. Right. So any very important processes in which you need to control the pH, and pH కొంచెం స్లైట్గా మారిన ప్రాబ్లం వచ్చే లాంటి ప్రాసెసెస్లో బఫర్ సొల్యూషన్స్ ఆర్ వెరీ యూస్ఫుల్. బఫర్ సొల్యూషన్స్ విల్ హెల్ప్ కంట్రోల్ దట్ pH. ఒకవేళ pH 8 కావాలంటే వీ కెన్ చూస్ అ బేసిక్ బఫర్ and make sure that the pH of the solution does not change by using the right reagents. Basic buffer add chesi right proportions lo mix cheyali. As we saw here, basic buffer వాడినప్పుడు POH. ఒకవేళ salt ఎక్కువ అయితే it becomes more basic, and if salt is more, it becomes less basic, because POH పెరిగితే బేసిక్ నేచర్ తగ్గుతుంది. POH ఎక్కువ అయినప్పుడు we know that POH equal to minus log of OH minus, so that minus indicates that POH increases, OH minus concentration decreases. OH minus concentration decreases means basic nature decreases. So this salt, if the concentration of the salt compared to the base is more, then POH will increase, and so basic nature decreases. So according to that, we can adjust the ratio of salt and base to control the pH or POH, depending on what you use, basic buffer or acidic buffer. Used in sophisticated processes to control pH. Industrial and in laboratories. Okay. Next, buffer solutions by themselves, we don't have to do anything. In our blood, we have a buffer of carbonate. Carbonate buffer is there in our blood, maintains a pH of 7.35. By itself, it is generated in our blood. The ratio is maintained such that the pH does not change much from 7.35. Change of pH in blood will obviously result in death, because only certain conditions are satisfied and certain enzymes require this pH to function in the blood properly. Next, not just in our blood, in many biochemical reactions, in plants, in other animals, everywhere, buffer solutions are very important. By themselves, they occur in nature. Artificial buffers are used in industrial processes and in laboratories. But in nature, you can observe many buffers. For example, the carbonate buffer in blood, and in plants, we also see other buffers which help maintain the correct pH for certain enzymes to work. In the cytoplasm, you'll see some buffers which maintain the pH which is required for the enzymes in the cytoplasm to work properly. Because enzymes are very selective in nature, and they only work in certain conditions, which includes the correct pH. Okay, the third application is hardness of water. Hardness of water estimation. In this process, ammonia buffer is used in this estimation of hardness of water by EDTA method. EDTA is a complex, metal complex. EDTA is not a metal complex. EDTA is a ligand. It forms metal complexes to precipitate either calcium or magnesium as a red precipitate, which using NH3 buffer is controlled how much it precipitates. It is made to precipitate fully so that we can measure the hardness of water properly. Next, applications are not that important, they're only theory based. They should be added to tonics and syrups to keep pH value constant. In medicines, obviously not in solid medicines, buffers are solutions. So in tonics or syrups, they are added to keep the pH at a constant level. Now coming to the problems. First problem, 50 ml of 0.2 molar CH3COONA and 25 ml of 0.2 molar CH3COOH were mixed together to form the buffer solution. pKa of CH3COH is 4.8. Find pH of solution. You can take your time to solve this question. I will continue. You can pause the video and try to solve it. If not, you can continue with the video. Now let's see how many moles of CH3CONA we have. 50 into 0.2 is 10 millimoles because we're taking in milliliters. CH3COH 25 into 0.2, which is 5 millimoles, right? Finally, volume is same, so their concentration is 10 upon V and 5 upon V respectively. Now we know this is a buffer because this is salt of weak acid in strong base, and this is that same weak acid. So we know it is an acidic buffer. pH equal to pKa, which is 4.8, plus log salt by acid. Concentration of salt is 10 by V. Concentration of acid is 5 by V. V cancel. 5 2s are 4.8 plus log 2 is 0.301, 0.3, which is equal to 5.1. Right. One more thing I would like to mention is this formula pH equal to pKa plus log salt by acid is known as Henderson's equation for buffers. In this case, for acidic buffers. Right. You can pause to understand if you didn't. Right. We can move forward. Second question ఏంటంటే, what is the pH of a buffer solution formed by mixing 20 ml of 0.1 molar NH4Cl and 2 ml of 0.1 molar NH4OH. BKB for NH4OH is 4.8. You can pause to try this question or you can continue. Right. Now number of millimoles of NH4Cl is 20 into 0.1. 2 millimoles millimoles. NH4OH 2 into 0.1, which is 0.2 millimole. And finally, since they are mixed, the volume of the solution is same for both, and we can find the concentrations by dividing like so, 0.2 by V. Right. Now we know from Henderson's equation POH equal to PKB, which is 4.8, plus log salt is NH4Cl 2 by V by 0.2 by V. V cancelled. 4.8 plus log 10. 0.2 times 10 is 2, equal to 4.8 plus 1, which is 5.8. But we want the pH. pH equal to 14 minus POH. 14 minus 5.8, which is 2. 13 minus 8 is 13 minus 5 is 8. 8.2. 8.2 is the pH. Right. That is it for buffer solutions and also for the chapter. With this, acids and bases complete chapter is completed. Next will probably be some basic concepts of chemistry. Thank you.